Hello everyone, welcome to the third and final part for the 2.8 notes. We're going to talk about something that I referenced in the first video when we were first introducing this idea of the algebra of functions, where we were saying that you can have functions and then you can do these operations like adding, subtracting, multiplying, and dividing functions, which we've seen a little bit of those, and then I added this fifth one here, which is a little circle, and this operation is called composition. And the way that you pronounce it is called composition, but the way that you pronounce this operation whenever you have it between functions, for example, you go f of g. And so this one is pronounced of. And there is a definition for f of g of x, which I think gives a better idea of what it means, and it also is indicative of the pronunciation thereof, because that's how you would pronounce this symbol that we have here. The way that we write this notation, this also you would call f of g of x. So the way that you pronounce these two things is exactly the same. They're both called f of g of x, but I think this one is more favored for me, this particular more favored for me, this notation, because it's more obvious what you need to do about it. If you just write this one, it's not so clear what it's supposed to mean, and sometimes it can be tricky, like if you can't remember the order or something like that. But f of g of x, that's what we're getting in here. And so basically what we're going to do, which you can tell by this one, is that we are just going to be plugging in, or else substituting, plugging in g of x for x in the function that's f of x. So the same way that before in f of x we've plugged in all kinds of things. You can plug in numbers, you can plug in expressions and stuff like that, you can plug in letters or whatever, these kinds of variables. But what we have here is we're going to purposefully plug in the whole function, this whole expression of g of x, into our function f of x. So why don't we actually see how it's going to work. Of course, for example 13, we're seeing this notation here. I'm just going to follow it up by writing this means f of g of x, which what that means is that we would want to take f that's going x there is squared, and then we have minus 3 times of x and then plus 1. What we want to do is instead of x there, we want to put g of x. So it's really going to be g of x and then squared, and then goes minus 3 times of g of x, and then it will go plus 1. And since we have an expression for g of x, we see that g of x actually is just 5x plus 4, so we can plug that one in, 5x plus 4 squared, and then it's going to go minus 3 times of 5x plus 4, and then at the very end it's going to go plus 1. And so here there's a little bit to do. I'm just going to come right on the side over here. I don't mean to cross that whole thing out. It's going to go this one. I just want to come to the side here and figure out what is 5x plus 4 and then squared, so that we can just write it all in the same line. Of course that means 5x plus 4 and then times 5x plus 4. And so we're going to have to FOIL this one. When you go 5x times 5x, of course 25x squared. And then it's going to go 5x times 4, so plus 20x. Then it goes 4 times 5x again, so plus another 20x. And then at the very end it goes 4 times 4, so plus 16. So it's going to be 25x squared plus 40x plus 16. So now I'm going to come back over here and replace this one with what we found. 25x squared plus 40x plus 16 is our thing, 5x plus 4 quantity squared, and then we will need to distribute this minus 3. So it's going to go minus 15x minus 12 also for the negative 3 times 4, and then we have at the very end plus 1. So now we just need to simplify this one. We have a few like terms. What about this 40x minus 15x? We can combine that one, and that will give us 25x. So in general, we don't have any other x squared, so I would just write the 25x squared. And then we have the 40 minus 15x, so it will go plus 25x. And then we have a few of these constants. We have plus 16, And so 16 and then minus 12. 16 minus 12 is 4, and then we need to add the 1, so it will go plus 5 at the end. That will be all of our constants combined. And so that is f of g of x. And that does it for us there. It's possible as well to do g of f of x, and you will get something different usually. Especially here, since f and g are different things, then for sure you will get a different thing for g of f of x than we got for f of g of x. And so you could work that one out. What about, it might be interesting to talk about maybe one more of these. I'll try here just plugging in something, because we will get some practice with doing square roots as well. Why don't we try this one, doing g of f of x, which of course that means g of f of x, like this one, which means we will plug in f of x for x inside of the g function. So the g function is going square root of 5 times x. So it goes square root of 5 times of x, and then it goes plus 5. But instead of x, we want to actually put the whole f of x there. So for this x, we will put this whole expression for f of x, which was 5x squared minus 1. And then we can just distribute this 5 inside of here. So it will go 25x squared minus 5 and then plus 5. The minus 5 and plus 5 is very convenient. Those just go away. So it becomes square root of 25x squared. And then square root of 25, it's possible to take that one out. And also here what we have, it's kind of a funny situation, because this whole thing inside of here, 25x squared, is a perfect square, and it's possible to take the square root of that and it just becomes 5x. So that is what we would want to have, but there's a problem here, because you can imagine in this function, if you plug in a negative value for x, it's actually going to give you something positive, because you're going to square it. So for this to be exactly the same function as what we have before, it actually would be necessary to put some absolute values on this one, because always, no matter what you plug in for x, you're going to end up getting a positive value for this. So we don't want to take square root and end up getting some kind of negative values. That would not be good. So this would be the answer for this one. It's a little bit tricky, and it's easy to miss that one, but that will be our answer for g of f of x for this one. So I hope this was helpful. Of course, it's not particularly new. We've practiced plugging in stuff into functions before, but here we're just seeing a nice new notation for it with this composition operation. So anyways, that does it for 2.8 altogether, and I will catch you guys in the videos for the next section. So thanks.